When a problem refers to z sub n, they're referring to the set of distinct equivalence classes for congruence in modulo n, which doesn't sound great. It's a lot of jargon. So what it is that we're talking about are the equivalence classes for 0, 1, 2, all the way up through n minus 1 when we're talking about a problem in z sub n. So let's take a look at an example and see if we can make a little bit more sense out of this when we're talking about an actual value rather than just n in general. So here I have z sub 4. And so this is the set of equivalence classes 0, 1, 2, and 3. And each of those are their own set. So the equivalence class for 0 includes the value 0, and then 4 because 4 is n, 8 because 8 is a multiple of 4, 12 because 12 is a multiple of 4, and it would continue on in that same pattern. So these are all the values for which we would get a remainder of 0 when dividing by 4. So remainder equals 0 when divided by 4. All right. Then we have the equivalence class for 1. 1, 5, 9, 13, and so on. So these are all one more than a multiple of 4. So for these, the remainder equals 1 when dividing by 4. And then we go on. So then the equivalence class for 2 would give you a remainder of 2 when dividing by 4, and the equivalence class for 3 gives you a remainder of 3 when dividing by 4. So how do I do computation then in z sub n? Let's take a look at an example here. So now I want to find the sum or product in z sub 4, and I'll start with 3 plus 3. So I'll go ahead and just do the computation. Oops, sorry about that. There we go. All right, we'll do the computation in just regular set of integers, and 3 makes 6. Now, since 6 is greater than or equal to 4, what I'll do is I'll divide it by 4 and see what remainder I get. So 4 into 6 goes 1 whole time, and my remainder is 2. So in z sub n, I'm not going to say that 3 plus 3 equals 6. I'm going to say that it equals 2. And so that's my final answer. I do something similar when I have 3 times 3. 3 times 3 is 9. And then I have to divide the 9 by 4. It goes twice. And, oops, put up here. So then I have a remainder of 1. So 3 times, oops, keep touching the wrong thing here. Okay, so 3 times 3 equals 1 because we're talking about mod 4. So 1 is my answer there. And then I have 2 plus 2, which is 4. And that's greater than or equal to 4. So I'll divide it by 4, and I get 1 with a remainder of 0. So 2 times 2 equals 0 in mod 4. And so that's how you do those problems involving z sub n.